This is Module 1, Lesson 8 for Grade 6. The page number is S.29. The first part of this exercise 1 asks, circle any equivalent ratio from the list below. So using what we know about ratios and determine whether or not they're equivalent, we can use some of the methods we've already tried. If you recall, we learned that 1 times 5 is 5 and 2 times 5 is 10. If that works and both green numbers, which are the little c, are the same, then the two ratios are equivalent. So we can circle the first two. Next, we'll look at 6 to 16 and 12 to 32. Well, the way we can get from 6 to 12 is by multiplying it times 2. And the way we can get from 16 to 32, and if you're not sure, on the side you can do 16 times 2 to see if that's correct, is by multiplying it by 2, which means that these two ratios are the same. They are equivalent. Another way you could have done it was taking 12 and dividing it by 6 to get the 2. Okay, next it says find the value of the following ratios, leaving your answer as a fraction, but rewrite the fraction using the largest possible unit. That's a lot of extra words for basically, they would like us to look at the value, which we discussed very briefly in Lesson 8. The value of the ratio would be the fraction, the ratio and the fraction in its simplest form. So, if we take 1 to 2, and we wrote 1 over 2, there's no way to simplify that, so that is already at its lowest form, and that's the value. If we take 5 to 10 and wrote that as a fraction, we could simplify that by dividing both by 5, thus giving us 1/2 as well. So the value of 5 to 10 is also 1/2. 6 to 16 would be written as 6 over 16. If I divide both of these by 2, 6 divided by 2 is 3. 16 divided by 2 is 8. That will give us 3/8. You can't go any lower than that. Thinking about our divisibility rules, it's not possible. So we can write 3/8 as the value. That's the 6/16 in its simplest form. 12 to 32 can be written as 12 over 32. Again, you can use your divisibility rules to determine what it can be divided by. You could definitely divide it both by 2. You could divide them both by 3 because 2 plus 1 is 3, but 3 plus 2 is 5, so you could not divide them both by 3. 4, if you know your 4 table, you could divide them both by 4. So let's do that. Let's divide them by 4. You could divide them by 2 twice, and I'll show you that in 1 second. 12 divided by 4 is 3, and 32 divided by 4, because you use the multiplication chart or because you know the 4 tables, is 8. If you were doing it 12 divided over 32, and you divided them both by 2, you would have gotten 6 over 16. Wow, that's the one we already had. And then you could continue to divide them by 2, and then you would have gotten 3/8 at that point. Both of these work. One is just less work than the other, but know that you can do them both. You can stop by dividing by 2 and just keep dividing by 2 until you get to the final point where you can no longer divide. So in this case, it's 3/8. The question asks, what do you notice about the value of the equivalent ratios? Well, hopefully you notice that 6 to 16 and 12 to 32, while we determined above that they were equivalent, you can also see down below by finding the value, which is the ratio written as a fraction in its simplest form, that the value is also the same. So one way of determining whether or not ratios are equivalent is to write them as a fraction, simplify them, and see if the two fractions have the same simplified value. Now we're going to skip exercise 2 as it's just extra information that will probably confuse you. And we're going to move to exercise 3. Tavon is training for a duathlon, which is a race that consists of running and cycling. The cycling leg is longer than the running leg of the race. So while Tavon trains, he rides his bike more than he runs. During training, Tavon runs 4 miles for every 14 miles he rides his bike. Identify the ratio associated with this problem and find its value first. Well, we just learned how to do that. We know how to find the ratio, and to find the ratio, we look at the words for every. That brings us to our actual ratio. And it looks like what's being compared is running to riding his bike. Running and riding would be 2 R's, so we're going to say bike instead. So our ratio would look like this. Running to bicycle. And it looks like he runs 4 miles to the 14 miles that he rides. Okay, so the ratio is 4 to 14. Identify the associated, also find its value, sorry. So to find the value of the ratio, we need to write 4 to 14 as 4 over 14, and then we need to divide and write it in its simplest form. Using the divisibility rules, you can know that since they're both even numbers, we can divide by 2. 4 divided by 2 is 2, and 14 divided by 2 is 7. This is the value, because you can no longer divide 2/7 by anything. That's the simplest form right there. So then it says, use the value of each ratio to solve the following. Okay, so when Tavon completed all of his training for the duathlon, the ratio of the total number of miles he ran to the total number of miles he cycled on his bike was 80 to 280. Is this consistent with Tavon's training schedule? Explain why or why not. So basically they've given us a second ratio and they want us to see if it is consistent. Consistent means, is it equal? So let's look at the first one. We had running to bikes, and that was, let me write that as a, actually as a fraction. Running to bikes was 4 over 14. They called it cycling, we called it bicycle. It's the same thing. And we found that the value was 2 to 7 when we simplified it. This new one he ran and biked was 80 to 280. And since running came first, and there's our ratio, and cycling came second, 80 goes with the running, 280 goes with the cycling. So what we need to do is see if these are the same. What we just learned on the previous page is that if we find out what the simplest form is, and it's the same as the original simplest form, we will be all set. So let me get rid of my writing here. What can I divide top and bottom by initially when I am simplifying? Well, because there are zeros on the end, I can automatically divide them by 10. And that will leave me with 8 over 28. Now, because they're even numbers, I can divide them by 2. I might be able to divide them by another number, but 2 is easiest, and I know many people are used to working with 2, so we'll start with 2. 8 divided by 2 is 4, and 28 divided by 2, if you don't know, you do it on the side, is 14. Now I can continue and divide by 2 again. 4 divided by 2 is 2, and 14 divided by 2 is 7. Now we could have done 8 divided by 28, we could have done 8 over 28 and divided them both by 4. And I would have skipped a step and immediately got to the 2/7. Both of those work. Just wanted to show you that. All right, so now the question is our value of the first ratio the same as the one of the second ratio? So the first ratio, the value was 2/7, and the second ratio, the value is 2/7. Therefore, they must be equal. So as you can see, I started writing, this is consistent because the ratio of the number of miles he ran to the number of miles he rode his bike is 80 to 280 has the value of, and we need to write 2/7. Because I'm typing it, mine's going to look like 2/7, but it will be the same as this one up here, which is the same value as the ratio of 4 to 14. And that's basically what we just said. I just wrote it in sentences, so go ahead and make sure that gets written in your book that way. Nice and small if you need to. Okay, C says, in one training session, Tavon ran 4 miles and cycled 7 miles. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? The same question, they actually use the word equivalent here. And so we will look, let's do this on another page so that we can, so I can show it to you better. Okay, so what you see here is that same question. I'll read it again. I just put it onto another page so that I can have more space to write. You're at the bottom of your page. In one training session, Tavon ran 4 miles and cycled 7 miles. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? Explain why or why not. So the new one that they just gave us was he ran 4 miles and cycled or biked 7 miles. So that would be running over biking, 4 over 7. Can we simplify this any further? Well, they're both not even numbers, so we cannot divide top and bottom by 2. There's no 3, no 4, no 5, no 6, no 7. So we can stop there and say there's no way we can simplify this anymore. This means it's in the slowest form, which means it's simplified. This is the value. And this is the original value. Are they the same? Clearly you can see they are not the same. And so here, when the question asks us, did this training session represent an equivalent ratio of the distance he ran to the distance he cycled, you can say, no, the session does not represent an equivalent ratio of the distance he ran to the distance he cycled because, and here's where you explain, the values are not the same. So I'm going to go ahead and type it here while you start writing on your paper. Okay, so this training session does not represent an equivalent ratio of the distance he ran to the distance he cycled or rode his bike because the value of the ratio here is 4 to 7, 4/7, which is not the same as 2 to 7 or 2/7. It means that they're not equal. And that's all I need for that one. And now we've come to the problem set, which is S.31. So you are going to do the problem set on your own today. I'll walk you through a little bit of it though. Number 1 says the ratio of the number of shaded sections to the number of unshaded sections is 4 to 2. What is the value of the ratio of the number of shaded pieces to the number of unshaded pieces? So you're going to put shaded to unshaded. You're going to write the original ratio. Here's our ratio word, here's 2. And then you're going to write the value, which is simplifying it. Number 2 says, use the value of the ratio, which means you need to simplify it after you write it as a fraction, to determine which ratios are equivalent to 7 to 15. So the value they're giving you is 7 to 15, which is written as 7 to 15. So your job is to turn each one of these into a fraction, simplify it, and see if it equals 7 fifteenths. 3 says, Sean was at batting practice. He swung 25 times, but only hit the ball 15 times. A says, describe and write more than one ratio related to this situation. That means they want you to think about how you could write a ratio and label it. So, for example, swings to hits, swings to total, hits to swings, things like that. Okay, so that's A. And then B says, for each ratio you created, use the value of the ratio to express one quantity as a fraction of the other quantity. I want you to create at least 2 ratios. 4 would be better. 4 is achieving an overachieving amount. So at least 2 ratios will get you what I want for tomorrow. And then for B, they want you to find the value of the ratio to express one quantity as a fraction of the other quantity. So basically write the value of the ratio for both of them. And C is make up a word problem that a student can solve using one of the ratios and its values. You don't have to do C right now. That will take too long. 4, I don't want you to worry about right now. We'll do that in class. So your homework this evening is to do problem set number 1, 2, and 3, A and B. Thank you.